We already knew OSS. Yeah. It's like so simple now.
Alright everyone, let's go ahead and get started. So before we get into announcements and stuff, we're going to try this thing. Maybe each lecture we can start doing this. This is one of those fun geography games I was talking about last time. This is a game called Global. Okay, it's kind of like Wordle. The thing is, like, every day there's like a different country, okay, and maybe I thought we could like sort of guess it together. I'll explain how it works. One rule here though is, since it's like the same thing every day, try not to do this before lecture. If you come in already knowing it, I'll do an AI violation, okay? Let's keep it like, you know, fair and stuff. Okay, so the way this works, basically, like someone just say a country, any country in the world. Which one? Ukraine. Okay. So then it'll tell you how close, like compared to what other countries you've guessed, how close this one is. Let me actually just hide these loading meeting controls. Okay, so right now obviously Ukraine was the closest one, and it's like orange, which I think means it's like warm, but not like super close. So let's name another country that we think it might be.
UK.
Okay, let's do, I wonder if it would say, let's do England. Okay, it maybe was. Okay, Iceland is cooler. So we want to be, it's going to be in the other direction maybe. Or maybe to the right, or maybe down. So use your geography knowledge. What do you think? Yeah, go.
Monaco.
Monaco. Whoa, okay, it's warmer. That's a good sign. Wow, it's so small. Okay, so maybe it's somewhere in between, somewhere in Europe maybe. What's up?
Portugal.
Portugal, okay. Portugal is warmer too? What? Okay, maybe somewhere over here. Any guesses? Let's go over there.
Burkina Faso.
Oh yeah, maybe it's in Africa? Oh, it is in Africa. Okay, probably in Africa. Next one. This can get really difficult actually. Yeah, go ahead.
Algeria.
Algeria. It's cooler. Okay, let's go a little bit more south.
Rwanda.
Rwanda. Okay, cooler. So maybe somewhere over here. Yeah.
Malawi.
What's up?
Malawi.
Malawi. Even cooler. Let's go. Yeah, go ahead.
Liberia.
Liberia. I'm gonna guess Benin. Okay, warmer. Let's do Ghana. Go ahead. Yeah, I guess.
Kenya.
Kenya. Cooler. I wonder if you can give up. Oh, it'll say 420 miles. Okay, that's pretty big. Closest border. So it's about 420 miles from Benin. Someone can also pull up Google Maps if you want to. If we get like 10 guesses, maybe we should start. Yeah, go ahead.
Equatorial Guinea.
Okay. Adjacent to the answer. Okay, so it's gotta be somewhere here. Yeah. Sudan. I think Sudan is far right? So.
Gabon.
Which one?
Gabon. G-A-B-O-N.
Yeah. Oh, I thought it was G. Adjacent to the answer. Okay, we gotta get in the next two. This is taking more lecture time than I thought. Yeah, go ahead. Angola. Oh my god. Where?
Republic of the Congo.
Okay, let's do DRC. Almost. Do we have Google Maps over? We should.
Uganda.
Uganda. Okay, let's maybe start using Google Maps. Yeah.
Wait, I finished it. Do you want it?
Oh, you got it?
Yeah.
Okay, let's get one more guess and then we'll take the answer. Anybody know? Yeah. Cameroon. Nice. Okay. That was a long. Okay. Maybe I won't play on my own, and we can see like how we're doing over the quarter. Hopefully, we get a little bit better, maybe. Okay. So I just wanted to start that. Maybe we'll start doing that each lecture. Seems like a kind of fun way to get the class started. So a couple announcements. The Canvas should be set up now. I think probably in the last like 30 minutes. It just happened. I've been emailing them a lot over the past couple days, and now I think if you check your Canvas, you should have access to it. So maybe y'all can check that and just give a thumbs up if you're able to. Okay, I see a couple thumbs up. Awesome. The financial aid survey should also be up there too. I think it'll be under quizzes, so you can just access it by filling that out under quizzes. All right. Another reminder about the pre-course survey, I think I saw only 41 responses, and I know like at least 50 people are enrolled, and if you're on the wait list, you can fill it out as well too, in case you do get into the class. But also, yeah, just make sure to fill it out sometime by the end of today. Even if you fill it out by the end of the week, I'll still give you credit for like lecture 1 participation. We really just want to make sure we have all the answers so that it's really helpful for us to understand what the students are like in our class. Okay, the last announcement is that assignment 1 is going to go out today. It'll be due in a week. I know we haven't really talked at all about what assignment 1 is yet, but after today's lecture, it'll be pretty clear what y'all are going to be doing, okay? So, are there any questions in general actually about logistics or class resources, anything like that? Yeah.
I think I need access to see the slides.
Oh yeah. So that good question. I thought someone would ask that. I'm just hiding it for the first like 20 minutes until I reveal the code base, and then I'll make it like everybody can view it with the link. Are there any other questions about anything with the class logistics before we get into the content? No other questions? Okay, cool. So the material for today, we're going to go over like open source software. We're also going to talk about like development environments, and then a process called building. Okay, building in terms of like building software, not like building like construction and stuff. And then we're also going to talk about the code base and sort of a little bit of background about the code base, just so you all know what we're going to be getting into this quarter. Okay, so what is open source software? Actually, just by a raise of hands, how many of y'all have heard about open source software before? Okay, most of y'all have heard of it. Does somebody want to just try to like share a bit about what they know about open source? I know you can see some stuff on the slide, but I think this isn't super descriptive. Does anybody just want to share what they think open source software is? Yeah, go ahead.
So the way I understand it, like the source code is out on the internet so that anyone can look at it, modify, and contribute towards it.
Yeah, the source code is just like out there on the internet for anybody to view, modify, sort of like copy and modify. Yeah, that's pretty much what it is. There's sort of some nuances between it. You can see on the slide here, those are kind of like the main purposes of open source. People can examine, modify, and redistribute it. I also do want to emphasize though, I'll explain more about what open source is, but I know like it's really hard to get internships at this like point in like based on how the market is, and there's just so many people in computer science right now. Internships are pretty like low in like supply, I guess, but open source software is something that, like we just mentioned, is like available anywhere on the web. And it's open for like anybody to actually contribute to, okay? So in the case that you don't have any internship experience or you don't have like projects that you really can add to your resume and stuff, open source software is an amazing way to get the experience of like working on a large code base, but more importantly, like having the code that you write be implemented somewhere and like actually used by people, okay? So I really do want to recommend this as like something that y'all can actually do. By the end of this class, the goal is like y'all have already made significant contributions to the code base that we're going to be working on. Spoiler, it is an open source project. But you can actually, start making these changes for the specific code base we're going to be working on, but also exploring other code bases as well. So I will share these slides in a little bit. You can click the link to this thing called Good First Issues, okay? This is a sort of like database of a bunch of open source projects that are specifically designed for beginner open source contributors to start working on. So you can like filter it by language based on what you are more comfortable with. You can see a description about like what the actual project is. And the nice thing about this is that there's these things called like issues in an open source like project on GitHub. There will be a little tab called issues. I'll show you in a little bit for our specific project. But you can actually find these like very hyper-specific bug fixes or small feature additions that don't require like, you know, months and months of work. It'll require a little bit of time to understand a part of the code base, to make the change and conform to the code style. But these are like really good ways to like add something specific to your resume as like I contributed to this open source project. You can even include the link to the commit because it's all available on GitHub. And so I highly recommend this if you're looking for things to do without maybe an internship this coming summer or something like that. Okay, so a bit about open source. I personally think this is really interesting, but I admit that like maybe something with like the licenses and like copyright might sound a little bit boring. But as you know, someone who's like really into this whole like free software movement, I think this is like really interesting. There's a couple different types of like open source licenses. I'll just focus more on this restrictive one. This is something that's like to make fun of like copyright. It's called copyleft, and the idea is that you make this like open source project with a copyleft license, and it means that anybody can use it for free, and then they can even like modify it without having to modify it and like use it for their own purposes without having to like pay or anything like that. So it's really like just intended for like public good, sort of, where there's very little restrictions on how people can like modify it, and then how people can then like repurpose it, basically. And so, yeah, this is sort of just an in-depth explanation of copyleft. But open source has like a huge history in a lot of the things that like we work on today. You'll notice like a lot of familiar sort of like projects here. You can see like Android, Git, Python, Linux, GCC, GNU. These are some of the early ones. Just go through a few of these, like the history of open source. I want to actually first point out this 1982, this GNU project announced by Richard Stallman. So this guy is like so awesome, actually. This is just a link to his Wikipedia, but he was sort of like one of the first main like advocates of like free open source before it was all, you know, very restricted, like, you know, copyright heavy software. And the goal, this person has like first created this like GNU, which is one of the first original open source projects, and then started this company called, not company, I guess it's just a foundation or organization called Free Software Foundation, and its whole mission is sort of dedicated to spreading this like open source culture and encouraging people to, you know, make changes to these open, like make these software projects open source, basically. So I think just a good maybe name to know, or just a little bit of context for open source development. And just a few more sort of like familiar projects here. Python is actually an open source project. MySQL is sort of a like a language for interacting with backend databases. That's also open source. Then you can see stuff like Git, JDK, Java Development Kit, and GitLab more recently. Okay. So I also just want to share one more crazy thing that happened. This I think, I promise, is interesting, more interesting than licenses maybe. I don't know if y'all have seen this on maybe your Twitter, or I first saw it on an Instagram reel, and I was like, why am I saying open source Instagram reels? But then it's actually really interesting, okay? So there's this like pretty big open source project called XZUtils, okay? The name is not so important, but basically it's for, if you ever have like a really, really massive file, and you want to compress it into something called a tar file, like if you've ever seen the extension .tar, that's what this like project does. It compresses it, and then it can also extract the data from this compressed file. So this was like a 2-year-long like social engineering like hack kind of. There's this account called Gia Tan that was making like good contributions to XZUtils, and the sort of like after backtracking and sort of seeing the full history of the interactions of this account, it seemed like there were some like fake accounts or some like co-conspirators, I guess, that were making feature requests and like pointing out bugs, and then this account, like Gia Tan, was fixing a lot of them. So it seemed like a very like good maintainer. These open source projects are typically maintained by like one lead maintainer, and then there's a bunch of other people that are also working on it. And so there's also something in the past few months, the lead maintainer of XZUtils was saying it's getting very hard to like maintain this, like it's all just like a side hobby, they don't get paid or anything, was talking about some like personal issues, some mental health issues, and then this person, Gia Tan, was like, oh, I can be like a second maintainer basically and also contribute to this. And then what happened just in the past week was, so there was like a full 2 years of like small little changes to this like software project. And then this is like the actual story, which is crazy, is some Microsoft like software lead noticed that it was taking half a second longer to SSH into their like environment. And then because this is like, so you can do something called profiling, we're gonna talk a bit about it later, but when you profile like a certain run, you can see like how the amount of time that each sort of like sub-component is taking to run, okay? So you can see like, oh, when like loading in and running like this package, it took this much time. This package, it took this much time. And so like they were able to like profile this like logging into SSH and see how long certain things were taking. They eventually like tracked it down to the XZUtils like packet or like project loading in. And because it's an open source project, the like Microsoft lead was able to look into the commit history, see the changes in the past few months, and then track it down to like certain commits made by this person. Okay, and so what was actually happening is this thing called a backdoor that this like account had actually installed into XZUtils. I don't know all the technical details about this backdoor, but the takeaway from the article that is like linked over here is that basically it allows this threat actor, GATM, they call it a threat actor, to basically like run any code arbitrarily if somebody has used SSH and is like connected to the internet basically. So it was like a pretty dangerous, like they say it was like a crisis averted and stuff like that. Some people are saying it's like a failure of open source because like now this is like a good model for like building up some credible reputation and then doing something malicious. Other people are saying it's like a win for open source because it's all like publicly available and you can see the exact changes that were made and you can track it to certain people. If you're interested, you can actually read the article, and they also have like the dialogue between Gia Tan and the original maintainer. It's pretty interesting stuff, but just a little bit of like helpful context for what open source is and some of maybe like the pros and cons of it. Are there any questions on just like this background about open source or anything I sort of just went over? Okay, admittedly this is a bit separate from just working with large code bases, but I thought this is a pretty helpful like context and background to what we're sort of getting ourselves into here. Okay, so all right, the big reveal, the code base. So the code base is something called idle, okay? This is the simple Python IDE that actually comes installed with any like version of Python, okay? I'm actually just gonna do a bit of like a demo on what idle actually is. So let me make this larger. Let me do, I think, preferences, settings. Let's make this size like 22. Okay, can people see this? Is it okay? Okay, so it's, a very simple IDE, right? Think of like, VS Code, like PyCharm, Eclipse. Some of these are more like high-powered IDEs that professionals will use. Idle is something more intended for people who are learning how to program for the first time, okay? So it's one of like the starting IDEs that people will use when they're learning to program, and it's not really designed to support like working with large code bases and stuff like that. Just maybe some helpful context. Gerald Susairaj, who's my advisor, and Soren Lerner, who's another, he's actually the department chair in CSE. This was what they used to teach CSE 8A before, basically before COVID happened. So it's like very commonly used in like intro courses and stuff to help people who are like learning Python for the first time, okay? And so because of that, the functionality is a bit limited. You have this Python shell. Okay, this Python shell is where you can type in specific commands and just see the output. So something like this, print hello. All right, you can just do simple lines like this. You could also do like several lines. You can do for I in range, whatever, 5. And then you can actually like keep adding on some code to this. So let's just say print I. Then you press enter twice and it'll print it out, okay? So this is like one component of idle. This is the Python shell. And then I'll show you the other component of it, which is like the actual editor. So this is, just simple like creating a file. So you do print hello, and then let's run it. So one of the somewhat annoying features on idle is that you can't just run it without saving it, which I guess makes sense based on how this is implemented, but you would have to first like actually save it into your file system, and then you can run it, and then you see the output in the Python shell, okay? So this isn't too crazy. It is actually a quite simple, simple like end product, I guess. I just want to show a couple more features actually, just because there were a few features in this that are pretty interesting. So let me actually just, okay, awesome, I have this open. So say we did have like a really big file. This is a file from like a research project I was working on. There's a couple of cool features I just want to point out, and then you can start maybe exploring these features once I show you the code base and show you sort of the code structure of it. So for example, you can do like show line numbers, and this will just like show the number of line numbers. But the more interesting one is show code context. I had no idea what this code context thing was. Yeah, I don't even think VS Code has it actually. They might, but this is sort of like when you have a really large file and you maybe have multiple levels of code. So like you're within a class, and then you're within a method in that class, and then within like a conditional block in that class, it just shows it at the top when you're scrolling. So this is kind of interesting that some maybe like a relatively like not very high-powered IDE has a pretty cool feature like this. But I would sort of recommend y'all to look around and like play with some of these features. It's going to be really, so we're going to be working on this code base throughout the entire quarter. It's really helpful to kind of understand the actual product that we're going to be working with to get an understanding of like what the source code is also like how the source code relates to the actual product, okay? You might start playing around with certain features and notice some similarities between them, or some opportunities where you can, maybe reuse some code in like multiple of these features, okay? So yeah, I just wanted to give that high-level overview of the code base. Just a couple of quick facts about it here before we get to the first activity. So yeah, it's written fully in Python, which is good. We wanted the emphasis on this to not be like y'all learning a new language and figuring out how this new language worked, but more about understanding how you would work on the large code base, assuming you already sort of know the language, okay? So there are going to be some advanced Python features that you probably haven't learned, especially like at least in UCSD's curriculums, some like maybe advanced object-oriented programming concepts. But that's something y'all will sort of be able to learn on the fly. For the most part, the concepts in this code base are not like overly complicated from like a programming language's perspective. It's 128 files and about 23,000 lines of code. But I do want to emphasize, like, compared to how big some code bases actually are in industry, this is actually like pretty small, okay? So this class is called Working with Large Code Bases, and you are learning the skills for working with large code bases, but just for like some context actually, if you look at our course website, if you look at the course website, this like graphic that we have on the home page shows the number of lines of code for these different like projects and products. So this is sort of the scale over here. This is like 100,000 lines of code. And so it's saying like a simple iPhone game app has 0.01 of 100,000 lines of code. So that would be, I guess, 1,000 lines of code. But then you can see like how quickly this starts scaling to millions of lines of code. And I think the largest thing is just all of Google's internet services, which is 2 billion lines of code, okay? Ours would fall somewhere over here. I think ours is 0.2. So ours will be, I think 20,000 of 100,000 would be 0.2. Yeah, so it will be somewhere over here. So obviously there's much bigger code bases out there, but we felt that this code base is large enough to help y'all get an understanding of the skills of working with large code base, okay? So I just showed y'all what code base we're going to be working on. The first activity that we're going to do today is actually to have y'all find, so hopefully y'all installed Python in your, on your computers before lecture. I think actually a lot of computers now have some version of Python pre-installed, and idle does come with every version of Python. So we're going to give y'all maybe like 5 minutes here to just try to find the source code for idle, okay? Not the location of the app, like there'll be maybe an idle.app file or something, but try to find the actual source code for idle, okay? And then also make sure to fill out this lecture participation form. This is how we're gonna sort of give you credit for it. And there's a couple questions for you to answer there. If you do finish early, you should sort of explore the idle application. And then also you can try to start reading through the code for code context, okay?
Idle built in Python.
I'll maybe tell you after the activity, I guess. But take some time to sort of explore where this might be in the course, or where this might be on your laptop. Oh, to the slides. Yeah, let me do that right now. Thanks. Okay, y'all should be able to access the slides now. You can also just type in this bit.ly link as well. It's CSE 190-4-4-1. The 4 is to the date, and the 1 is to the first activity. I'll do 2 more minutes. Don't worry if you don't find it, but still make sure to fill out the link in the Google form, whether or not you find it. Okay, it looks like people are still working, so I'll give maybe an extra minute or minute and a half on this. Okay, let's now just with the person next to you or the couple people next to you in front or behind you, just talk to each other, let them know if you did find it, and then also talk about what things you sort of tried to actually find the source code, okay? So make sure you also fill out this Google form, but then just discuss in groups for a couple minutes.
No, that's possible.
Okay, let's come back together as a group now. I'm just curious, can you raise your hand if you think you found the source code for idle? Okay, I see like 6 hands maybe, not bad. This was kind of difficult, right? Let's talk about what things some people tried. Let's say if you didn't find it, what were some of the things that you tried? And also before you tell us, like, do you have a Mac or a Windows? Because I think there's a different process for the two operating systems. Someone willing to just share what they tried? Anybody? Okay, yeah, go ahead.
I have a Mac. I was just trying to use this. I was trying to find it with like a Finder.
Okay, what were some of the things you searched?
I just clicked idle. Because I used it with Gerald in like GCA days.
Oh, nice. Okay.
On the app, but I didn't know the source code.
Okay, so like just somewhere over here, right, where you're just searching idle, and I'm guessing it took you to like, maybe you just find the application, or okay. Anybody else? What are other things people tried? Yeah, in the back there.
I went into my terminal and then I started using like LS and CD, and so I found.
Oh wow. Okay. Did you find it? You think?
Yeah, and then I used like PWD to get the path.
Yeah. Oh, nice. Okay. Awesome. Okay. Anybody else try something different from those? Yeah, in the back there.
I guess I have Windows, and I actually kind of just tried poking around like the kind of C directory. Wasn't really able to find it. It's at ChatGPT. I was just curious, and so kind of like suggesting like where it might be pop up.
What did ChatGPT say?
It was the right answer actually.
Oh, really?
So it was like Python 3.11, in C, then lib, then idle lib. And so.
Nice. Okay. And then you were able to pull that up in your own. Okay. Awesome. Did anybody else use ChatGPT? You raise your hand if you used it. Like one person. Okay, so the reason I was also asking about Mac and Windows, I think in Mac actually it's a hidden folder. So if you try searching things like idle or idle lib, even this it's showing up in mine because I have, I'm teaching this class and I have it in a separate place. But if you do just search idle lib, which is the actual name of the folder, the actual location for it won't show up for you. Did anybody try Googling it? Anybody Google it? Okay, a couple people, a few people. Okay, so I'm just gonna show y'all what happens when you Google it, like where is the idle source code I would specify in Mac because it is. There's actually like a perfect Stack Overflow post with somebody asking about where the source code for idle is, and there's also this amazing answer from Carrie Jan Rainey. Okay, this person actually is I was mentioning how every open source project has a maintainer for it, the person who's the CEO of that open source project basically, that's like Terry. So they're like very involved in all the like C Python open source changes, and they got back with like a great answer, right? So you can actually try this. You can just open up the actual idle application, and you can go to File, Open Module, and then idle.idle, and it'll tell you the exact location. The reason I also wanted to point this out though is because this was me like 2 years ago. This was like 2 days into grad school. This was like, we were actually working on this for a research project with Gerald actually. We wanted to add an extension where every time students press run, we would get a snapshot of their code. I was talking a bit about my research in the first lecture, but we were just trying to like add an extension in idle to like do data collection for a research project basically. And I struggled for like several hours just trying to find it in my like directory, doing different searches and stuff, and it was just so frustrating because I could never find it, right? But I wanted to emphasize this because it's surprising. We did the same activity last year, and very few people think to just like Google it as like a first option, you know? And I don't know why. I think, you know, one hypothesis is that we're not typically taught to use these online resources as like a help-seeking tool, but like really they are, okay? And especially stuff like posting on Stack Overflow. The other reason I wanted to emphasize this is like C Python and idle is part of like a really large open source community, okay? There's so many people that are like actively contributing to this, monitoring the Stack Overflow with things related to C Python. So if and when y'all inevitably run into struggles to understand part of the code base, Stack Overflow, Google, ChatGPT, it sounds like there are a bunch of like really helpful ways to find the answer you're looking for, okay? You don't have to just struggle on your own, you can also make use of these resources. Actually, sorry, one question for the ChatGPT person in the back. Sorry, did it recommend this thing in the answer, or maybe let me pull it up? I'm just curious if it uses the same like tokens from this, or it had a different answer. Does it say you open up the idle application and you go to File, Open Module, and then type something in?
Yeah, so it kind of gave you like a numbered list of steps. It's like C, then Python 311, and then like, so kind of gave it
Okay. So it's something different from this. Okay, interesting. So there are like a couple different ways to make it work then. Awesome. Okay, so the other reason I wanted to do this activity is also to motivate this idea of development environments. Actually, first, I'm going to talk a bit about C Python. So C Python is like the massive open source project that is just like the full implementation of Python, okay? Remember in that list of open source projects, Python was one of them. I think it was introduced like 1991 basically. But C Python is like all the code that goes into having like the Python programming language, and the output of all of C Python. So those like stats I showed earlier, like the 23,000 lines of code, 128 files, that's just like one small part. That's just of idle lib, okay, of the idle application. There's like so many more parts of C Python that are not idle lib, okay? There's like all these different sort of like subdirectories in idle lib. Of C Python, sorry. Idle lib just is like one subdirectory in lib, okay? So just for some context of like what we're dealing with here, it's this really massive open source project with so many different parts, right? And you can see like the different components of it. There's stuff for like documentation, stuff for like different objects that you can have in Python, etc. And then this is also like the actual language breakdown of C Python. So one sort of interesting thing here is that C Python is written like mostly in Python, but then like a third of it is actually written in C, which is pretty interesting. This was just some reading I was doing to prepare for this lecture, but I didn't realize that when you create a new programming language, you have to write it in a programming language that's already compilable. So like you can't write Python and then use like a Python compiler because it doesn't exist yet. There's nothing that can actually, you know, compile a bunch of Python code. So it's like one of some languages. Then originally they like, I think one language called Go, which was originally created at Google. It was written in like Java or something. I might be misremembering what it was originally written in, because there were only like Java compilers at the time. There's no compiler for Go. But then once you have this programming language that you create and compile in another language, then you can create a compiler for that language. So now Go is written in Go. They have like changed from what it originally was. C Python didn't change away from C. A lot of the code is still maintained and written in C. But again, the part that we're dealing with is fully Python. The idle-lib implementation is fully Python. I don't think you'll have to deal with any non-Python language. Maybe a little bit of HTML for a couple features, but it'll be only Python. Okay, so yeah, one other cool thing about C Python is that you're going to be doing this in project 1 actually. You're going to be like building C Python, okay? Now I'll explain what building actually is, but the sort of takeaway here is that the whole like output kind of C Python is just like a single executable file that just lets you run Python code, okay? So let me actually show, I think like python.exe maybe, will this show up? Okay, maybe it's not showing up when I search it here, but if you've ever like run Python code from your terminal, so I think I have something called hello.py here. When you type in like Python 3 and then like hello.py, this is just hello.py. You have to be in the same directory as some existing like Python file, and then you run it. It's just a very simple, like it just prints out hello. But what you're actually doing with this like Python 3 is specifying like an executable file name. So there's a file name called like python3.exe or something in your computer, and that is what's actually just running any Python code, okay? So what we are going to be doing is having like our own version of C Python that of course has a subcomponent of it that is idle, and we are going to be creating like our own executable by like building and configuring our version of C Python, and then we're going to be making edits to like our version of idle, okay? But I'll be going over all of that right now. I think that might have sounded a bit confusing and disorganized, but hopefully, based on the next few minutes of lecture, that'll start to make sense. Are there any questions, though, about just like what we just covered with like C Python, idle, anything like that? Anything people are just curious about or want to know more about? Okay, cool. So, yeah, just to emphasize this point, there's like a huge Git repository of C Python. If you just Google like C Python, basically I think the first result will be this Python/C Python Git repository. And you can actually see, like I was saying, this thing about the issues tab. There's over 5,000 like open issues. You can like do these different filters. It's for open issues, which basically means that these are like open requests for things that people can work on in the open source community. So you can like scroll through these. You can also like filter for different things. Okay, maybe I thought there was like, oh, maybe you can do it on labels. So you can look at these different like labels for these different issues and sort of like filter down your search to something that you're more comfortable with. I think this will be more relevant once you all have gone through this course and explore different parts of the code base and start to see things that you might actually want to contribute on. But you can see there's like, oh, it looks like there's over 5,000, so like 7,000 open issues. So these are basically like open invitations to the community to like make these fixes or feature additions, and then you submit a pull request, which is just like a final submission saying these are all my code changes, these are why I made these code changes, and then people review it, and then if it's good enough, I mean, they'll probably ask you to make some edits and changes to conform with code style, or maybe it's just like something's a little bit wrong, but then if it's good enough and like valuable and addresses one of these issues, then it'll just be like integrated into the next version of idle. There's also like different like testing phases. There's like an alpha and beta version of every Python where they'll check to make sure these new changes didn't break anything, but just a really like sort of an interesting thing here that y'all could honestly contribute to several weeks into this class, I think. Okay. So, one more activity actually before, just to motivate this idea of development environments, which we're going to get to in a little bit. So, hopefully y'all have been able to like actually find the idle source code. Yeah, we have time for this activity. So, if you didn't, just, you know, you can go to this specific Stack Overflow post and just get to the actual idle lib source code in your like computer. It should be the actual like, you know, the version of idle that's associated with this like Python that you downloaded before this class. And just go to this specific file. I mean, honestly, it'll work with any file, but I just want to like have y'all introduce something that would cause a syntax error, like, I don't know, delete a semicolon or just like add some gibberish somewhere, and then save the file, close the file, and then just try opening your idle lib directly, okay? Or try opening your idle lib app. Yeah, just take a second to do this. If anything, it'll also just help you realize where this is in your computer and introduce you a bit to the file structure of it. So it'll just take maybe a couple minutes. We don't spend too long on this. Sure, yeah. Save the file, close it, and then just try opening that idle application.
Wait, what semicolons? Like you don't have actual semicolons.
Colons. What I had done is I really did a colon. But you're right, you're right. I think you can pass it.
You can.
I don't think it's actually a symbol. Okay, let's just come back together then. It's okay if you weren't able to fully do this. Honestly, I just wanted to emphasize this point. So, let me actually go to my implementation of idle. So, go computer. Okay. Okay, so let's just go to code. Should be idle lib here. Okay, cool. So yeah, hopefully y'all were able to just like get to idle lib in your file system using the directions in the Stack Overflow post. I'm just gonna make some small change to the code somewhere. I'm just gonna add like a couple semicolons to a line that definitely doesn't need semicolons. Just save it, exit it out, and then when you try to open it, it should just like not work. I think it'll just bounce a little bit and then not do anything, okay? So this was maybe a sort of long-winded demo, but I wanted to get across the point that what we just did is we made an edit to the production version of idle on our computer, okay? That thing that we just like edited, I'll need to remind myself to delete those changes later so it doesn't stay broken. But we made a change that was wrong to the production version, and then now we don't really get much information on like what caused the error, what went wrong, and now we're going to have to maybe go through some long-winded process to fix this bug, okay? So this, I sort of did that to kind of motivate this idea of the difference between a production and a development environment, okay? So when y'all are eventually in industry and have to work at a company that has some like, software output, you're definitely going to like interact with these things that are called environments, okay? So this is just two types of environments. There's a development environment and production environment. I'm going to go over the sort of other types of environments in a little bit. But the main difference here is we call these things development environments that are just sort of like local environments on our own machine that we can sort of edit without any real consequences, okay? These are sort of meant for a developer to be like experimental or making bug fixes or making changes and to like test out those changes before merging it or moving on to like the next sort of stage or the next environment, okay? So you can see some of like the differences here. Like the development environments won't be like fully set or like ready for production. There might be like some things in the front end that are not fully set up, or it might take a little bit longer to like load certain things, but the intent is not for it to be like good performance or something that's like ready for production. The idea is it's made for a developer to be able to like experiment and make changes. So there might be more powerful debugging features, but that comes at the cost of performance, okay? By contrast, the production environments are like user-facing environments. So this is like by the end stage after like idle has been built and reviewed by the internal team and maybe has like an alpha phase, a beta phase, and then is like sent out to users. That would be like the production version of it, okay? So there were a couple interesting like instances of like when things sort of went wrong in this like development environment versus production environments like thing at different companies. So this happened I think maybe like a few years ago. Everybody who's like subscribed to HBO Max just got this email that just says integration test email number 1. I don't know, I find this so funny, like if you know what this kind of like means and you just get an email like that, I think it's like hilarious. But the real issue is just that there's like a disconnect between like a developer thinking that something was just in like the test environment and like sending some sort of request to test out, probably to test out the email notifications in like a non-production environment, but they actually just did it in the production environment, okay? And as a result, everybody got this. So this is ultimately like a kind of harmless example. There are cases where this has gotten like a bit crazy. This admittedly is not exactly the fault of like a developer at a company, but basically what happened was there's like a test system for like the Hawaii missile defense and an actual like production system basically. And the person who like accidentally sent this out, sort of, it was like actually a result of human error, but just misunderstood like which sort of like system they were sending out this notification in, whether it was just like an internal test or something that would go out to everybody. And obviously, as you can see, like it would, I mean, it even says like not a drill, which is like crazy to like see. And then it took a whole 38 minutes to like issue that this was just like a false alarm basically. But yeah, just to sort of like let you realize like what the difference is and like the stakes here of making sure we go through this rigorous testing process before anything is sort of pushed out to production, okay? So I said there was like a development environment and production environment, but there are actually a lot of these like intermediate environments that requires a bunch of different sort of like types of testing before something reaches its final state, okay? So I already went over local development and production. I'll just go over a little bit what integration, testing, and staging are. You can see these differences here, and I'll also qualify this with, I don't think every company has this exact like setup of 5 different environments. My industry experience just comes from working at Amazon for a summer, so I think we didn't have this QA environment, we just had like 4 different environments. But like my girlfriend works at Apple actually, and they have a QA environment where there's a whole separate team of engineers that are just QA engineers. And so they work like solely in this QA environment, which is set up to, not exactly to replicate production as much as possible, but it's set up for QA engineers to test all the features that have, you know, passed the local and like integration environments, okay? But this is sort of like a breakdown of what these different versions are. I'll point out this like staging environment is pretty interesting because it's supposed to kind of replicate the production environment like fully, but not actually be, you know, visible to end users. So the goal here is to be like, say this was actually in production, we'll test it out on the variety of different like operating systems that people can be using, different like environments people could be using, and trying to basically find any bugs that might happen in a production environment, okay? But again, this is, I think, more of an abstraction just for you to realize what the different types of environments are. It can definitely vary from, I think, like company to company or project to project. But the idea is you actually have to like pass your change through these different phases, and sometimes the tests are a little bit different. So like, for example, the QA environment might have more like end-to-end testing. End-to-end testing would be like full back-end to front-end. So like, see how some front-end interaction will propagate all the way to the back-end and then happens to the front-end. That might not be the goal of testing in like the integration environment, where it might be more unit testing for just like the software feature that you added, if that makes sense. We're gonna have like 2-3 lectures about testing in general, like unit testing, integration testing, etc. But this is maybe just a bit of an overview of what we are doing in this first week, which is just setting up our local environment, okay? We are only gonna really have a local environment and production environment, but I think it's helpful to know that there's all these other stages in between there, okay? Are there any questions on this? Anything people are just curious about? Okay, cool. So, all right, so what we are going to be doing in project 1 is building from source, okay? So I mentioned earlier that C Python is like all this different code that helps us create like an executable that can just run Python code. There's sort of like 4 steps in this. The first is just getting that source code, okay? The source code we already showed is like posted on GitHub. Anybody can actually just like install that and make modifications, compile it, and build it, etc. We also have this really important step of installing dependencies or libraries. So this sort of process of building is kind of meant to, I think I have a slide about it next. Let me just go to this right now. So what building really is like shipping out just like the programming, like the code for the specific program, and then like a list of all the dependencies or libraries that are needed to just like create or like compile all the code into whatever the final product should be, okay? And so there's a lot of different ways to do this also. If y'all have heard of something called like Docker, when I was in undergrad, I just kept hearing the word Docker, but I really had no idea what it was. It's essentially like, they call it like a Docker container or a Docker image. But it's basically, it's quite like simple, I think, once you learn about it, but it's just like a list of a bunch of dependencies or like Python packages that you might need for like running a certain like Python project or something. And given like all that list, the list of all those dependencies, you're basically, you just go through each of them, install each of those dependencies, and then it ensures that whoever is running this source code has like the environment ready for them. So the goal of building is to get past this situation where we have some people on Windows, some people on Mac. We're actually like automating that whole process to fit whatever like environment or system somebody's on, okay? So it's like a pretty cool way to, it also helps in just like having more tests. When we build something, there's a bunch of specific tests that are going to be run to make sure that there's no errors that are gonna eventually like, you know, make it so that the production version can't run properly. There's also like this static code analysis phase where there's like a whole line of research work on static code analysis, but the idea is like, given just the actual code without, you know, executing anything, can we like make conclusions about what things might lead to errors or what things might go wrong? Maybe we have like some insecure code or something that we can tell just by the actual like text of the code rather than like running the code and seeing what things might be going wrong. So this is another process that typically happens during builds where there's just like an extra check for whether the changes that we made or whether the code that we have is going to lead to any issues. It also does improve collaboration just because building is sort of this idea of letting people make modifications and then build like whatever software they've made modifications on and then can disseminate that. So rather than like sending out whatever the final product is, this allows people to sort of like make edits before building, and then we have this like sort of exchange of like code changes and code edits to whatever platform we have. So yeah, just back to here, after we install the dependencies and libraries, there's going to be some like settings that we have to configure, just telling it we want to use like this much compute or this much space during the building process, and then we'll output something called a makefile. I'll go over what a makefile is in a second. And then we just run this make command to basically execute the contents of that makefile, okay? So I'm going to go a little bit in depth on what make and makefiles are. So a makefile is just like so a makefile is the output of like all the different like C files, Python files that we have in the C Python code. We'll have like a single file that will tell us like relationships between a bunch of files and then maybe like the libraries or packages that it depends on. So this is actually just the structure of a makefile. By the way, I'm going to be putting like links to all of these things that basically like cite my sources, I guess. If you're curious about any of these things in further detail, you should like click on the link and you can read more about it. But this sort of structure of a makefile is pretty interesting because it kind of like, think of like a tree if you've taken an algorithms class. You can sort of see the like children of a certain file, which represent the things that that file depends on. So you can see like a target file that's like the whatever parent node. You can see the things, the dependencies or the like objects that it depends on. And then you can see like the files that are responsible for like implementing that object, okay? And so the reason this is pretty useful is in a lot of like large code bases, building something takes a really long time, okay? For idle, I don't think it'll take that. For CPython, it doesn't take super long. But when you eventually work in industry or work at like a big tech company, you might be sitting there for like dozens of minutes basically, like waiting for something to configure and build, okay? And the goal of these make files is actually to reduce the amount of time that we have to sit through building and configuring something if we make like a change to one part of the code base, okay? So given that like that tree diagram that I was just showing, we can see like what different dependencies impact a certain like target or whatever. And when we make a change to that dependency, then we can see like the things that are impacted by it using that sort of tree structure, right? So the goal with this is to know what things we actually need to like reconfigure and rebuild when we do make some edits to a specific like part of the code base, okay? And so, yeah, the goal of these things is to basically like limit the amount of time that we have to wait to sit through like a whole build process. And you're going to be doing something very similar in assignment 1. I'll go over assignment 1 in a little bit more detail, but you're at a high level going to be following these sort of like 4 steps. And also just to like motivate this a bit more, when you do like join a new company, like a lot of the first like several weeks or months, you'll go through something called onboarding. There's even like research related to this, like what is the best way to like onboard like new employees to a certain like code base, like onboard them to a tech stack, help them set up their development environment. But one of the biggest components of onboarding is this like getting your development environment set up. There's so many like specific commands that you'll have to, and so much like documentation that you'll have to read through to actually just follow this like relatively simple process of just like configuring and like setting up your development environment. This is just like a abstraction, kind of like a simplification of all the different steps that you'll go through just to set it up. It could take like weeks just to like get yourself ready to start making changes to a code base. Are there any questions about like makes or make files? Yeah.
I'm having trouble following with makefile stuff. So let's say I edited source file 1. In that case, it would have to recompile the dependency one and target, or just dependency one?
I think just dependency one, and then, so I think the executable is this part from the object files to the executable is not a very time-intensive part. That's my understanding of it, at least. That once you have the object files, creating the executable from it is not so bad, but I think this can be like quite wide, okay? Think of it as like having a bunch of different object files that's not very tall, but more like, I guess wide. I don't know how else to describe that part. So then I think the idea is that we would have limited ones of these like subtrees to sort of edit, and then that sort of limits the amount of time for, rather than going through each object. That's my understanding of it, at least. I'll admit that I think I'm probably not super well versed in how this all works, but that's my understanding. Is that a satisfactory answer, or?
I'm mostly just wondering if we update like the dependency, do we have to specifically recompile the target?
I would assume so, yeah. But I still think it's like a quite heavy like speed up, basically. Are there any other questions? Okay. Yeah, so for this class, what y'all did just now is you installed Python like somewhere in, like it'll have like an executable path. I think in Windows it'll be like C, program files, something like that. And then in Mac it's gonna be like in a hidden file under like frameworks and like versions or something like that. What we want to do is create a development version of CPython in like a different part of our file system that isn't where like the production version of idle is stored, okay? So we're actually just going to be having like 2 sort of like versions of idle that exist on our computers at the same time, okay? So to do that, you're going to be following some instructions that are actually part of like the CPython setup instructions. And this is for like how to set up and build a version of like CPython on your own machine, okay? And so you're gonna be doing this likely like if you have like a Mac, maybe somewhere in like your documents or something, basically away from where the actual like Python executable would be, and some place that I guess you would just want to store these like programming projects, okay? This is like finding a location for your development environment. Yeah, what you're going to be doing is we're going to release assignment 1 after this class, okay? I think probably by like 6 p.m. I'll send out an EdSTEM notification with like the actual link to the assignment write-up. Most of the instructions you have to follow though are on this specific webpage, which will be linked to the assignment. Some instructions are going to be left like intentionally slightly vague. This is like a pretty common experience where when you join a company, there might be some like outdated documentation or something that's not quite right. Maybe there's a step where you're running into an error that this doesn't mention, like to like expect running into an error. And so I would recommend you to like try to use some like something that we call just-in-time learning. That's like as you encounter a bug, you'll maybe like want to read up about why that bug is being caused. So you'll want to copy paste that error message somewhere, read through a few Stack Overflow posts about other people who have ran into that error and what they did to sort of address that error. And then if you keep running into that issue, then you should definitely come to office hours. But the priority here is to sort of independently resolve some of these bugs if you are able to. There are going to be these like issues that you run into, but just try to work through it for a little bit. Also, make EdSTEM posts about it because just in that spirit of like everybody collaborating and being like sort of like open and solutions that have worked for people, you can make like a public EdSTEM post about like an error that you're running into, and then we'll get back to you with our answer. And then if it works, then it's just like a Stack Overflow basically, but for the course, right? Where other people get to see issues that people ran into, and then maybe use that for their own implementation issues, okay? So yeah, do your best to maybe post about it on EdSTEM. If there was like, you know, a common issue that we've seen in office hours, we'll do our best to post that publicly on EdSTEM as well. One other note here is that for Windows users, okay, so I have a Mac. I think among our tutor team, everybody else has Windows, I believe. So there's honestly probably, if you're having like a Mac specific issue or Windows specific issue, you might want to like go specifically to someone who has the same type of computer as you, because there were like last year there were some specific issues with Windows users. We do recommend using something called WSL2. That's like Windows subsystem for Linux. This is like, I think it's not technically a virtual environment, a virtual machine, but it basically helps you run a Linux environment on a Windows. So for configuring CPython and then making edits to the idle-lib codebase, this is like a much easier way. You can also like, you'll have this like active in your VS Code as well. I don't know all the details of this. I actually haven't used WSL2. Like I said, I have a Mac, but this is what like our tutors will have used to like do project 1 as well. So they can help you with that setup. In our write-up, we're also going to have like a description of what you need to do to get WSL2 set up. I think there might even be mentions of it here, but if not, we'll have, oh yeah, they do have a whole description on Windows as well. But we'll also have we'll have our tutors be able to assist you if there's some issues with WSL2 that you run into. Okay, other than that, I think that is it for the lecture material today. I do also want to, before we sort of get to the conclusion here, are there any questions people have on Project 1 or like anything that we went over today? Yeah, go ahead.
I have both Mac and Windows, which one do you recommend?
I think you'll be able to do it in either. I think, to me, I'm more comfortable in Mac, and I think we did just have a few more like tech issues that we ran into with Windows. So I would probably recommend Mac, but like if you have Windows, you'll also be totally fine in this class. Yeah.
How many like we still get the EdSTEM notification?
Yeah, so okay, that's a great question. If you fill out the pre-course survey, my plan is to have all the emails from the pre-course survey be added to like the GitHub Classroom and the like EdSTEM. So even if you're on the wait list, I want to give you access to the course materials and the GitHub Classroom assignment and the EdSTEM. So make sure you fill out that pre-course survey. I'll also be adding all the emails from Canvas. So even if you're like an official student in the class but haven't filled out the pre-course survey, you should be added to it. But if you're a waitlist student, the only way I can get your email is through one of those like forms that you filled out. So if you make sure to do that, then we'll get you added to the like course resources that you need. Did that answer? Okay, awesome.
Will we be using package managers like
You can if you want. I think last year people used Anaconda. I don't think it really causes many issues, so you are free to use it.
separate production?
Yeah. This also helps with the idea of like isolation, basically. We'll have you can have your own virtual environment. Are there any other questions? Okay, so last thing, I forgot to do this at the beginning, but Jerry, you want to just like maybe stand over and come up here? This is Jerry. Jerry was also like heavily involved, like a co-creator for the class last year. And he just couldn't get enough of this class basically and wants to help out more with it this year. Do you want to just introduce yourself and maybe say what you're going to be doing, I guess?
I haven't figured that out yet. My understanding is that you might see me here occasionally delivering guest lectures or portions of a lecture. So yeah, I mean, this whole class is a project that I'm very passionate about because I think you have all taken 110, right? If you have taken 110, you know what I'm talking about. So, I mean, students have, last year I believe in 190, they have come away begging us to replace 110 with this class. Now, we're nowhere near production ready yet. We're still very much in the development environment. And you are our unit tests, basically. So it's a project that I'm very passionate about. So I'm still here using all of you as guinea pigs, trying to make this thing viable viable on a scale of maybe 150 students, 200 students, 300 students, and maybe one day it will replace 110. I think one of the 110 professors is actually right next door right now. Bill Griswold is next door right
now. Anything else?
Yeah, no, I mean just, you can also, I'm not officially on the staff, I'm not allowed to touch grading stuff, so don't try to come to me for any of that, but if you have any questions, I think you'll probably get my contact somehow.
Yeah, we'll add it to the course website. If you want to email him and just like set up a meeting or just ask something, he's not going to have like office hours and stuff. We're still working out exactly how he'll be involved in the class, but I just want to introduce him because he's also like he made some of the slides for today and it's like a big reason this class like is where it is right now, so he'll also be involved in the implementation. Yeah, question.
If we charge you, do we get extra credit?
If I like what you say to me.
Okay, that's going to be it, so look out for assignment 1 notification later today. Other than that, have a nice day everyone. See you next
No, it's so like.
Yeah, so you're welcome to like the window. part of the presentation. Because if there's no way to get out of it, we can find you can make a short video for your part and Oh, okay. Yeah, so don't drop this class just as a final. Really? I'm not, I don't really know what that is. That question was.
It's like tiny zero level actually teach how to process work. So when objects see files, it is
Yeah. But I'm not so sure about how the process works, so like why exactly it is.
I mean, I don't understand either, especially at the scale of C when you have like,
Did you watch 911?
Yeah, I did.
40.
Yeah, I was at the Do Good City when you
Oh, yeah.
That was super sad, but thanks for bringing up that lecture. Okay, for next Thursday, we're going to so if you want to like do a specific down or something, like maybe we can do like up to 10 missions if you want every. Even today, like
There's like a study where you can do that.
I think we're planning to try
Your knowledge, your primary.
Yeah. Oh yeah.
Like instead of talking,
I think that's not like
I don't know.
yeah.
I mean, I guess I just
so what's your
Oh yeah.
I know it's hard, I know it's definitely hard. Just like,
Okay.
pretty advanced.
So wait for your.
That's what I'm saying.
Wait for your.
Like,
Wait, so
What's telling he's not out he's not really.
So you said wait. Wait to everyone. So like
It's the same.
no, it's okay.
Like you were the.
I think right now it's not like I mean, it's not charged, it's not
Okay, I'm gonna head out, but although we also like worst case, we're not gonna get to get up for another like 3 weeks probably. So even if it's okay, alright. So
Yesterday, and then I think Stacy trained us up and did another among the two. Oh, credit review. Sometimes Porque that's like a really the same vibe.
那个代表工作呀，在不了。但你是做不出来。
I have a stage for the right now. So waiting for them to finish.
你怎么拖到现在？拖延一些。12个月，你这不相当于秋季？哦，不对，不是12个月秋季。完了，有些。好。我有的时候是也。